Hello friends, in this video we will explain the term reduced mass. Its formula is given as follows. If there are two bodies of masses m1 and m2, then their reduced mass is equal to 1 by mu is equal to 1 by m1 plus 1 by m2, where mu is the reduced mass. This gives mu is equal to m1 m2 by m1 plus m2. To explain the term reduced mass, let us suppose that there are two bodies of masses m1 and m2. Their position vectors are r1 and r2 from the origin O. If the position vector of the center of mass of the system be at C point and OC is equal to R, then m1 r1 plus m2 r2 is equal to under bracket m1 plus m2 into R, according to the properties of center of mass. Therefore, R is equal to m1 r1 plus m2 r2 by m1 plus m2. This is equation number 1. The figure is shown here. O is the origin of the Cartesian system of coordinates. The position of m1 particle is r1. The position of m2 particle is r2 from the origin, and the position of center of mass of m1 and m2 particle is at C point, where OC is equal to capital R. Also, the position vector of m2 from m1 point is vector small r. If the interaction force due to mass m2 on m1 be F12 and the interaction force due to mass m1 on mass m2 be F21, then F12 will be equal to minus F21. Therefore, F12 plus F21 is equal to 0. This is equation number 2. Now, if an external force F1e is applied on the mass m1, then equation of motion of mass m1 will be given as m1 r1 double dot is equal to f12 plus f1e. This is equation number 3. Similarly, if m2e be the external force acting on the mass m2, then the equation of motion of m2 mass will be given as m2 r2 double dot is equal to f21 plus f2e. This is equation number 4. Adding equation 3 and 4, we get m1 r1 double dot plus m2 r2 double dot is equal to f12 plus f21 plus f1e plus f2e. Using equation number 2, we get m1 r1 double dot plus m2 r2 double dot is equal to f1e plus f2e. This is equation 5. From equation 1, m1 plus m2 under bracket into r is equal to m1 r1 plus m2 r2, or m1 plus m2 under bracket capital R double dot is equal to m1 r1 double dot plus m2 r2 double dot. Using equation 5, we get m1 plus m2 under bracket capital R double dot is equal to f1e plus f2e, or m1 plus m2 r double dot is equal to F external. This is also equal to resultant force acting on the system, where F external is equal to F1e plus F2e. If the position of m2 from m1 particle be small r, then R1 plus R is equal to R2, or small r is equal to R2 minus R1, or small r double dot is equal to R2 double dot minus R1 double dot. Putting the values of R1 double dot and R2 double dot from equation 3 and 4, we get R double dot is equal to 1 by M2 under bracket F21 plus F2E bracket closed minus 1